Okay, we're here with Luke to talk about working with units. Ready to go?
Yeah.
Okay, so let's first talk about converting units. It's a very special thing to do, and then we'll talk about units in the real world.
Okay.
So first of all, let's talk about a conversion here. From 3.628 kilometers, we're going to try to convert that to a certain number of meters. Now, you might already know that. Do you know that off the top of your head? You might.
Would it be...
How many kilometers are in 1 meter?
Oh.
Do you remember from the metric system?
1,000?
It's 1,000, that's right. So if you knew that there were, each one of these kilometers was 1,000 meters, could you do some math in your head to get to meters?
Yeah.
What would it be?
Well, you could times it by 1,000, so multiply 1,000. Or you could move the decimal.
Good. How many times for 1,000 would you move the decimal?
3.
3. So if we move the decimal 3 times, what would you end up with over here?
3,628.
Good. So that's the right answer, and you can often do this in your head. But what you're doing in your head is you're doing something called using a conversion factor. Okay? So let's look at what this math statement says right here. We have our 3.628 kilometers, and we're going to multiply it, just like you did, by 1,000. But we're going to think about it using units, because that's what we're focusing on here, okay?
Okay.
So what we're going to multiply by here is something that says there's 1,000 meters in 1 kilometer. Okay? Now, what that thing is right there, that equals 1, because 1,000 meters is the same as 1 kilometer, right?
Yeah.
So we can multiply anything by 1 and keep it equal, right?
Yeah.
So we're just multiplying it by a very special kind of a 1, and that's called a conversion factor. The reason we want to do this is because it'll get us the right units, because we don't want kilometers, we want meters. So let's watch what happens with this. So then we can do something where we separate the numbers, the 3.628 and the 1,000 and the 1, from the units, the kilometers, the meters, and the kilometer. So that's what I've done here. Do you see how I've separated the numbers from the units?
Yeah.
And then let's watch what happens. We can go ahead and cancel kilometers. Just like you would cancel if you had a 3 in the numerator and a 3 in the denominator, you could cancel those out. You can do the same thing with units. And what does that leave us with for units?
Meters.
Meters, which is what we're looking for, right?
Yeah.
So we can do the math over here, which you were able to do in your head to get 3,628, and then all that's left on the right-hand side there is meters. Okay?
Okay.
So that's how we work with units. Just out of curiosity, you could convert this to kilometers. Could you convert it to something like gallons or minutes?
No.
So one of the things we always want to remember is that you can only use units that make sense, and you can only convert a distance unit to another distance unit. You couldn't convert a distance unit to a volume unit like gallons or liters, and you couldn't convert a distance unit to a time unit like minutes or seconds, right?
Yeah.
Okay, so we've learned how to use a conversion factor here. Let's really quickly talk about what it is that we use, what strategies and steps we use. So we use a conversion factor, you separate the numbers and the units, and you perform the arithmetic. And once you do that, you can cancel the units, and then you'll have the right answer. Now, why should you care? You should always ask yourself this with math. Well, using units like this, when you get to a more complicated problem, which we'll do over here, it really helps you make sense of the problem, and it catches mistakes. So if your units don't come out right, you can say to yourself, oh my gosh, maybe I didn't set up this problem correctly. So let's go try a problem over here that we can set up. To prepare for a marathon, Jeffrey does 4 running workouts per week. Each workout lasts 2.5 hours. Jeffrey runs 9 miles per hour. How many miles per week does Jeffrey run? Okay, so I don't know about you, but I get about halfway through this problem and I start to kind of like get confused. How about you?
Yeah.
Yeah, because there's a lot of words and there's some numbers, and it's really hard to know what to do with all of that. And that's why units can help you so much. Because if we just start setting up what we can maybe do with this, first, what is it that we're looking for?
Miles per week.
Miles per week. So just like over here, we wanted meters. Now the units we want is miles per week, right?
Yeah.
Okay, that's what we're shooting for. So let's start listing what we have. So first of all, we have 4 workouts per week, right?
Yeah.
Okay. Now part of that week is a part of what we want, right? Mm-hmm. Okay, so that's looking good. We want miles per week, so that's miles over week. Week is already here in the denominator, so it looks like it's in the right place, yeah?
Yeah.
Okay, let's list what else we have. What's another thing that the problem tells us?
Hour per hour.
Yeah, each workout lasts 2.5 hours. So here we have workouts up here in the numerator. Do we want workouts in our final units?
Yes.
Do we? Does that one?
No.
No, we don't. We want miles per week. So it'd be great if we could get a unit here with workouts in the denominator that would cancel with this workouts in the numerator, right?
Yeah.
So this statement that you just said, each workout lasts 2.5 hours. Can you think of a way to write that that's kind of like a unit rate with units? Like workouts per hour or hours per workout?
Yeah, hours per workout.
And how many of them?
2.5.
Good. So if we get this statement here and multiply 2.5 hours per workout, what's going to happen with these workouts?
Can cancel them out.
They're going to cancel out, right? So it looks like maybe we should do this multiplication here. And then what's the final thing that the problem tells us?
How many miles per week does Jeffrey run?
Miles per
hour.
So if we were to multiply that, let's see how that would work out. What would happen with these hours?
9 miles per hour.
Yeah, but what would happen with this hours and this hours in the unit?
Cancel them out.
Cancel them out. So let's watch what happens when we do our strategies over here of separating the numbers in units, because it's starting to look pretty good, right? So if we separate all the numbers over here, the 4, the 2.5, and the 9, and then we put all the units over here, then you can start to see that if you do the arithmetic, let's see, 4 times 2.5, what's 2 times 2.5? 2 times 2.5. What's 2 times 2?
4.
What's 2 times 2.5 then?
4.
You can do a little mental math. Well, first let's do it this way. If you had a quarter and you had 2 of them, how many would that be?
Half.
Yeah, it's a half, right? It would be 50 cents. And if you, I see what you're saying. Yeah, a quarter. I meant a quarter like money. What if you had 4 quarters? How much would that be?
$1.
$1. So 4 times 25 is like 100. What's 4 times 2.5 then? Let's do some mental math.
1.
It's close to 1, but you know it's got to be bigger than 4 and 2, right? So what's 4 times 2.5? What's 4 times 2?
4 times 2 is 8.
And what's 4 times a half? What's 4 halves?
2.
2. So what's 8 plus 2?
10.
10. So 4 times 2.5 is?
10.
Yeah. So sorry to take that little detour, but sometimes it's good to practice your mental math here. So that's 10. What's 10 times 9?
90.
Good. Now, you could use a calculator to do that if you wanted. Okay? Now, how about the units over here? What's going to cancel out?
Workouts.
Workouts are going to cancel. What else is going to cancel?
Hours.
Hours, right? So what will we be left with?
Miles and week.
Yep, miles per week. And that's what we can write over here. Now, what were we looking for up here?
Miles per week.
Okay, so it all worked out. And the reason we knew what math to do is because the units worked out for us. That's how it helps us to make sure we're not making any mistakes. So how many miles per week does Jeffrey run?
90.
All right, great job.